Hello friends, I am Amir Nizami and today we are going to just have a comparison study for deflections of simply supported beam and a fixed beam. So we know that the simply supported beam, that the deflection of the simply supported beam is 5 times greater than the deflections of the fixed beam or clamped beam. So first let us see that what the input required. So suppose if we are having a simply supported beam and a fixed beam, so both the beam is having a same length of 6000, width of the beam, depth of the beam, value of modulus of elasticity, number of elements, and value of distributed load on the beam. So these things are given, means on both the beam same load is acting on both the beam whose magnitude is equals to P equals to minus of 10, and length of the beam is same, and width of the beam same, depth same. So each values are the same, but the support conditions, only the variation is the support condition. Here it is fixed, and here it is simply supported, both end simply supported. So what is the variation in the deflection occurs due to the change in support conditions. So here we will study the change in support conditions. So if we changes the supports, so both end simply supported and both end clamped or fixed, so the deflection, we will check the deflection, that whether the deflection changes or not. So let's see. So simply supported beam, the maximum deflection, it is given the maximum deflection for the simply supported beam, which is equals to 5 times PL to power 4 upon 384 EI. So we are getting this value, and it is roughly approximately minus 6 and minus 7, so minus 6.25 or something around it, which is the maximum value for this simply supported beam. Okay, and we can keep the value here, so we will get the P value, L value, and 384 EI. So we will get these value, so it would be the maximum value. Here it is the maximum value which is here shown. Okay, so it is for the simply supported when the both end is simply supported and load carrying is uniformly distributed load, which is P is equals to minus 10 kilonewton per mm. Okay, next, so this is a fixed beam with the same, it is a fixed beam, both end clamped, fixed, you can say both end is fixed or fixed, and the maximum deflection for this is PL power 4 upon 384 EI. So this, it is showing that maximum deflection is at this point. Okay, which is equals to minus of 1.25, around, it is roughly around minus 1.25. Okay, so, and one thing more we can see that at this position the deflection as well as slope tangent to this is also 0. So here deflection is also 0 and slope is also 0, and at this end also deflection is also 0 here, and slope is also 0 here at this end. But in the last slide we can see that in simply supported one the deflection is 0 here, but slope is not 0 at this point A. Similarly, at this point deflection at B is 0, but slope at B is not equal to 0. This position we are telling B, and this position A. Okay, so now let us see the result of both. So now, so it is a combined plot for simply supported beam and fixed beam. That, so let's see with the orange color what it is showing. It's just showing that fixed beam. So fixed beam deflection, and it is simply supported beam deflection. Simply supported beam deflection.